Hi guys, I would like to explain about angle modulation in this video. But first, do you know what is modulation? Modulation is the process of changing the parameters of the carrier signal, in accordance with the instantaneous values of the modulating signal. Let me show you an example. And now, let's go to angle modulation.
What is angle modulation?
Angle modulation is the modulation in which phase or frequency of the carrier signal is varied with respect to message or transmitting signal.
There are two forms of angle modulation, namely frequency modulation and phase modulation.
In frequency modulation, the frequency of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. The equation for FM wave is St equals a cos WCT plus 2 pi kFMT, where AC equals the amplitude of the carrier, WC equals angular frequency of the carrier equals 2 pi FC, MT equals message signal. We can see from the waveform, the frequency of the modulated signal becomes high when the amplitude of modulating signal is high, and the frequency become low when the amplitude of modulating signal is low. Let the carrier frequency be Fc. The frequency at maximum amplitude of the message signal equals Fc plus delta F. The frequency at minimum amplitude of the message signal equals Fc minus delta F. The difference between FM modulated frequency and normal frequency is termed as frequency deviation and is denoted by delta F. Phase modulation is the phase of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. The amplitude and the frequency of the carrier signal remains constant whereas the phase of the carrier changes. Phase modulation is used in mobile communication systems. The equation for PM wave is St equals a cos WCT plus kPMT, where AC equals the amplitude of the carrier, WC equals angular frequency of the carrier equals 2 pi FC, MT equals message signal. This is the waveform for input signals and output signal of phase modulation.
What about the frequency shift keying and phase shift keying?
Frequency shift keying allows digital information to be transmitted by changes or shifts in the frequency of a carrier signal, most commonly an analog carrier sine wave. There are two binary states in a signal, 0 and 1, each of which is represented by an analog waveform. This binary data is converted by a modem into an FSK signal, which can be transmitted via telephone lines, fiber optics or wireless media. FSK is commonly used for caller ID and remote metering applications. FSK is also known as frequency modulation, FM. Let's see how the signal is being modulated in frequency shift keying. Phase shift keying is a digital modulation scheme based on changing, or modulating, the initial phase of a carrier signal. It is used to represent digital information, such as binary digits 0 and 1. PSK is typically applied in wireless local area networks, Bluetooth technology and radio frequency identification standards used in biometric passport and contactless payment systems. Now, is time to see the signal modulation in phase shift keying. Let's go.
Bessel function. Equation that expresses the phase angle in terms of modulating signal is solved with a complex mathematical process. Formula for bandwidth B equals 2n/fm. This is Bessel function table to calculate frequency spectrum. M is the modulation index, while n refers to number of the side frequency. Jn refers to Bessel coefficients. Another way to determine bandwidth of frequency modulation signal is by using Carson's rule. B equals 2 delta f plus fm. Delta f is frequency deviation. Total power of FM frequency is same as total carrier power, PC. PCE equals VC squared over 2 times resistance, which is equals 10 to the power of 2 over 2 times 50 ohm equals 1 watt. Therefore, frequency modulation is better than amplitude modulation because it saves power consumption, since only power loads is on carrier frequency only, and reduces noise and interference because amplitude is constant throughout the process.
Do you ever wonder how FM signal is generated? Let me explain to you. There are 2 methods of FM generation, which are direct method and indirect method. Direct method consists of reactance modulator and varactor diode modulator, while indirect method consists of Armstrong method. In a direct FM system, the instantaneous frequency of carrier is changed in directly proportion with the information signal. For direct generation of FM signal, 2 methods are commonly used. First, reactance modulator. Second, varactor diode modulator. And the formula for direct FM generation is appeared on the bottom right corner. This is a varactor diode FM modulator. When the voltage of modulating signal increases, the capacitance decreases, and the frequency of modulated signal increases. Meanwhile, if the voltage of modulating signal decreases, the capacitance increases and leads to a decrease in frequency of output signal. Everything has its pros and cons. Same goes to the signal modulation process. Next, we are going to discuss about the advantages and disadvantages of angle modulation. Let's go. Advantage of angle modulation. As the amplitude of FM carrier is constant, the noise interference is minimum. Angle modulation is capable of handling a greater dynamic range of modulating signal without distortion than AM. Angle modulation allows the use of more efficient transmitter power and information. Angle modulation improves SNR at the output of the receiver. Disadvantage of angle modulation. Angle modulation requires transmission bandwidth much larger than the message signal bandwidth. Angle modulation requires more complex and expensive circuits than AM.
Direct generation has weakness. It is lacking in terms of flexibilities. That is why indirect generation designs to easily manipulate delta F and carrier frequency. It can be generated by using nonlinear circuit to get multiplier and using mixer to change the carrier frequency. The combination of mixer and multiplier provides flexibilities. Armstrong modulator is one of indirect FM generation's method. But how it is working? First, it obtains narrowband AFM via a narrowband PM circuit with crystal oscillator. Then it is applied to the frequency multiplier to increase both carrier frequency and frequency deviation. If necessary, it will use as mixer to concatenate multiple multipliers. The following is the example for Armstrong modulator. This Armstrong modulator uses two frequency multipliers with coefficients of 162 and 30 respectively. The mixer provides frequency of 80 MHz.